All right, guys, we're looking at Unit 10, Skill 4. This is Miss Griffin, by the way, in case you couldn't tell. We have inside and outside angles in circles, so we're asking the question of what formulas are used and how do we use them when we have an angle that's inside the circle other than inscribed or central, and when we have an angle that's outside the circle. So we're going to start with these inside angles where the vertex is formed by two intersecting chords inside the circle. So you'll notice that this vertex is not at the center, so not central. And it's not inscribed, meaning not on the edge. And so we have a super special formula that says the measure of an inside angle over 1, because we love proportions, you know, is equal to the big arc plus the small arc divided by 2. So what this means, oh, by the way, you got to memorize this. What this means is that if I'm trying to find angle 1, say that that's x, it opens up to arc DC for sure. But also remember that vertical angles are congruent, so it opens up to this arc AB. This is the big arc, this is the small arc. So I average the two arcs essentially to find this angle. So I do big plus small divided by 2 will give me the angle. And one thing I want you to totally notice here is that these are all in a straight line. They have to be lined up in a straight line in order for you to add the arcs and divide by 2. So we're going to see one quick example, and then the other one's going to take us just a second. It's not going to be too hard, but, you know. All right, so this angle is not at the center of the circle. They don't tell us there's a center, so we've got it opening up to KL, so this looks like our big arc. And on the flip side of it, because of vertical angles, it also opens up to JM, which is our small arc, just simply based on the numbers and what I'm seeing in terms of size. If you can't tell the difference between big and small in this type of problem, no biggie. Haha, no biggie. Okay, so we know that this angle X is equal to the sum of the arcs, so 156 plus 130, and cut it in half. I could put this over 1, but it's not going to be helpful in this case because I won't need to cross multiply this since these are just numbers. So x equals 286 over 2, and therefore x equals 143 degrees. Nice and simple. They were all in a straight line. On this next one, when I try to capture that straight line, they're not in it. So I just have to do like 30 seconds worth of work and find out what this angle is. On a straight line, angles sum to 180. So 180 take away 102 means that that angle is 78 degrees. So I'm going to plop the 78 in here. Now notice that it's always the angle on the outside left side of the equation. So it's 78 equals big arc. I'll call this one the big one. So I've got 95 plus the small arc, y, and cut it in half. Now, I don't know how to cut this in half, so I'm going to put this over 1 so that we can cross multiply. 78 times 2 is 156. 95 plus y times 1 is just 95 plus y. And then you're just solving for y, so I want to get rid of 95. That gives me 61 equals y. Okay, not so bad. Trick is when you have chords that cross, they are making a plus sign, so you add your arcs. That's going to be huge because in the next one we're going to be subtracting arcs, so you got to remember the difference. All right, so on this page we're going to talk about these things called outside angles. So on the previous page we did inside angles inside the circle. These are outside angles outside the circle. Makes sense, right? These are formed by intersecting tangents or secants. So a tangent, remember, looks like this. It crosses over the circle one time, so that's the tangent. And a secant looks like this, crosses over the circle twice, and keeps on going. These have arrows on both ends. Okay? So an angle that's formed outside the circle is equal to the big arc minus the small arc cut in half. So we've got the big arc, the small arc, and then we cut it in half. We're going to write that formula down. Measure of the outside angle equals big arc minus small arc divided by 2. And we can put this side over 1. And again, this is a formula that you do have to memorize. Okay? Same thing applies when we have two tangents here. this angle, angle 2, is formed, and it opens up to a small arc, and it also opens up to a big arc. So we do big minus small, cut in half. Angle formed by two secants opens up to a big arc, a small arc, and we subtract and cut in half. Remember, a trick for remembering whether you add or subtract is if they are making a plus sign, that means you want to add. So this would be big plus small over 2. If they're on the outside, they don't make a plus sign, so then you subtract. So we've got 2 quick examples, and then you'll be moving on to your practice. So this angle here is formed out of a tangent and a secant, rather. Tangent crosses once, secant crosses twice. So this is my big arc, this is my small arc, and I'm going to do big minus small over 2. And so we've got x being the angle over 1 equals 178 minus 76 over 2. I'm going to simplify this top part, so I have x over 1 equals 102 over 2. I can just simplify this number, so I don't even need this over 1 anymore. So we have x equals 51. Okay, same idea as the other one. We just have to subtract the arcs this time. Here we've got 2 secants making an angle of 30 degrees. So we've got 30 over 1 equals big arc minus small arc. A minus 44, cut in half. Now in this case, because A is over here, we've got to cross multiply. So we have 60 equals A minus 44. Add the 44 on both sides, so we have A equals 104. Okay? Make sure that you go move on to your practice problems. You're going to want to practice in order to get really good at this skill. It's not hard, but it does take time and effort and practice. Okay? Otherwise, let us know if you have questions.